connected. Although self-awareness may functionally be viewed as if it is localized in the various whirlpools and eddies that self-organize out of the apparent atomies of matter and energy in the universe, these localizations are ultimately as meaningless as asking where the signal responsible for the image on a television screen is most powerfully focused in the actual picture. In other words, you can't break it down to individuals. It must be seen as a whole. In a meaning universe, what we perceive as a degree of consciousness in any given self-organizing entity is at least partially a measure of that entity's ability to tune into the cosmic backdrop of information. In other words, what we perceive as degrees of self-awareness in ourselves, mind you, and other self-organizing systems, is partly a measure of the transactions we, ourselves, or they are carrying on within the information picture of the universe as a whole at any given point in time. It follows that given the proper bifurcation point, that is, the proper influx of energy or the influx of information, it is possible for any self-organizing system, no matter how seemingly primitive, to suddenly and unexpectedly display an entirely new degree of self-awareness or attribute of mind. This ultimate non-locality of consciousness in the universe is perhaps why it is so difficult to pinpoint precisely where consciousness is located within our own biological brains. For if the what of consciousness is that it is pure information, in a meaning universe, the where of consciousness becomes alternatively nowhere and everywhere. In a universe that is infinitely interconnected, consciousness can be anywhere it wants to be. In the dance of neurons in our brain, in anywhere within the universe and starry systems. If that doesn't stagger you, there's nothing else I can say that will. That's amazing. David Bohm, again, in his astonishing, wonderful mathematical book, Quantum Theory. This is published by Dover Publications. The copyright's 1959, then it was renewed in 1979, and then the Dover edition is published in 1989. It's absolutely phenomenal in its literal discussion and outlook on the mathematics of the quantum. But what I wanted to get to, on page 161, he's discussing in Unit 16 the indivisible unity of the world. The world cannot be analyzed correctly into distinct parts. Instead, it must be regarded as an indivisible unit in which separate parts appear as valid approximations only in the classical limit, that is, only through the Newtonian physics. The properties of matter are incompletely defined and opposing potentialities that can be fully realized only in interactions with other systems. Thus, at the quantum level of accuracy, an object does not have any intrinsic properties. For instance, either a wave or a particle. It has none of those properties, belonging to itself alone. Instead, it shares all of its properties mutually and indivisibly with the systems with which it interacts, even if that system is the entire universe. Now, that's my comment, not his, but that's what he's saying. Moreover, because a given object, such as an electron, interacts at different times with different systems that bring out different potentialities, it undergoes continual transformation between the various forms, that is, wave, particle, wave, particle, wave, particle, in which it can manifest itself. He notes on page 162, at the quantum level of accuracy, the universe itself is an indivisible whole which cannot correctly be regarded as made up of distinct parts. The world must be regarded as an indivisible unit. Quantum physics further, on page 167, he notes the entire universe must, on a very accurate level, be regarded as a single, indivisible unit in which separate parts appear as idealizations, permissible only on a classical level of accuracy of description. The underlying structure of matter, however, is not mechanical. That is an astonishing conceptualization based on these new physics. Now, the brand new book on quantum physics that I just got, I try to update myself every couple of years by buying several of the new books. This is by Bruce Rosenblum and Fred Kuttner, Quantum Enigma, Physics Encounters Consciousness. This is out of Oxford University Press, 2006. I'll go to page 100. Niels Bohr, the defender of the classical famous Copenhagen interpretation of quantum mechanics, says the discovery of the quantum of action shows us, in fact, not only the natural limitation of classical physics, but by throwing a new light upon the old philosophical problem of the objective existence of phenomena independently of our observation. This confronts us with a situation hitherto unknown in natural science. Amazing. There is no official Copenhagen interpretation, of course, but every version grabs the bull by the horns and asserts that an observation produces the property observed. That whenever we refer to observation, the question of consciousness lurks. It's all about the conscious observer. On page 104, the Copenhagen interpretation generally adopts the simple view that only the observed properties of microscopic objects exist. Cosmologist John Wheeler puts it concisely: no microscopic property is a property until it is an observed property. In other words, atoms aren't real until they're observed. And if bigger stuff is made of atoms, then what is going on? This is the mind boggle of the quantum. If we carry this to its logical conclusion, microscopic objects themselves are not real things. Here's Werner Heisenberg's take on this. In the experiments about atomic events, we have to do with things and facts, the phenomena that are just as real as any phenomena in daily life. But the atoms, or elementary particles themselves, are not real. They form a world of potentialities, or possibilities, rather than one of things or facts. According to this view, atomic scale objects exist only in some abstract realm, not in the physical world. There's your mind blow right there. And this is amazing too. I skip over to page 200. We create the universe. Quantum theory has observation creating the properties of microscopic objects. In principle, quantum theory applies universally. If so, all reality is created by our observation. Going all the way, this is one of the quantum theories, the anthropic principle, the strong anthropic principle, asserts the universe is hospitable to us because we could not create a universe in which we could not exist. The weak anthropic principle involves a backward in time reasoning. This strong anthropic principle involves a strong form of backward in time action. Quantum cosmologist John Wheeler back in the 1970s drew an eye looking at evidence of the Big Bang, looking back at its own origins, and asked, does looking back now give reality to what happened then? The provocative sketch has not lost its impact. A keynote speaker at a conference honoring Wheeler on his 90th birthday introduced his talk with Wheeler's sketch. The anthropic implications of his diagram must have been a lot even for Wheeler to buy. After asking the above question, he immediately added the comment, "The eye could as well be a piece of mica. It need not be part of an intelligent being."